This example is going to work through how to solve an equation that has two radicals in it. So if I examine this question, 7 plus the root of 3x equals the root of 5x plus 4 plus 5, we should be able to identify that there are actually two radicals in it. The key here is to actually look at one of the radicals and decide which radical is a little bit more complex. So I have a 3x as a radicand and a 5x plus 4. Well, I would consider this one to be a little bit more challenging. So I want to isolate this one first. So in order to isolate that one, I need to move this positive 5. To move that positive 5, I simply subtract it from both sides. If I do that, I have 7 minus 5 is 2, plus the root of 3x equals now 5x plus 4 under the square root sign. So now I've isolated the more confusing radical, and we've talked about in previous lessons how to actually get rid of a radical is to square it. So if I square this, that's actually going to eliminate that radical for me. But what I do to one side of the equation, I have to do to the other, so I have to square this side as well. Now this raises a little bit more work, because right here I have 2 plus the root of 3x squared, so that actually means 2 plus the root of 3x times 2 plus the root of 3x. So now I'm actually going to have to multiply out those two binomials. So in order to do it, I have to actually be able to organize my work fairly well. I say 2 times 2, well that's a 4, and 2 times the root of 3x is 2 root 3x, and then 3x times 2, that's 2 root 3x, and now the root of 3x times the root of 3x, if I multiply two identical radicals, I simply am left with the radicand, so I get 3x there, and this still all equals the 5x plus 4. So now you can see on the left-hand side of this equal sign, we have some cleaning up we can do. The 4 is the only constant out there, but I have a 2 root 3x and a 2 root 3x. I can add those together and get 4 root 3x, and I have the 3x term, and on the right-hand side, I still have 5x plus 4 just sitting there. So now, just like we've done before, we want to now, because I'm left with one radical, isolate that radical. I want to get everything away from the 4 root 3x. So to do it, I'm going to subtract 4 and subtract 3x from both sides. So I'll subtract a 3x from this 5x term and subtract a 4. So what I'm left with on the left is 4 root 3x. And on the right-hand side, 5x minus 3x is 2x, and 4 minus 4 is 0. So that cancels each other out. So now I'm left in the same situation I was right off the beginning. I have a radical, and I need to isolate. I need to get rid of the radical. So in order to do it, I'm going to simply square this side, and what I do to one side, I have to do to the other. So I'm going to square this. Now, squaring the left-hand side, 4 times 4, that's 16, and then the root of 3x times the root of 3x is 3x. On the other side, I have 2 squared is 4, and x squared is x squared. So now I can just start piecing some things together. This gets me 48x and a 4x squared. So now I've gotten rid of all of my radicals. Now I want to move everything to one side of this equation, making it equal to 0, but I probably want to take it over to where my leading coefficient would be positive. So I'm going to move everything to the right-hand side, so I want this 4 to be positive. So I'm going to subtract a 48x from this side and subtract it from this side, and I'm left with 0 equals 4x squared minus 48x. Now let's try to solve a quadratic. This guy simply has a greatest common factor here. So I can factor out a greatest common factor of 4x. So if I do that, I'm left with 4x times x minus 12. And this whole thing equals 0. So like the quadratics we did in our quadratic unit, now I just take both factors, make them equal to 0, and solve for x. So here I'm going to divide by 4, so x equals 0. Here I'm going to add the 12, so x equals positive 12. So now I have two solutions that I should verify in my original equation to make sure that they actually are solutions to my example. So in order to verify, we always verify back in the original equation that was given to us in the question. So the original equation was 7 plus the square root of 3x equals the square root of 5x plus 4 plus 5. So now I have to do two verifications, one where x is 0 and one where x is 12. So for x is 0, I have 7 plus 3 times 0 equals 5 times 0 plus 4 plus 5. So that gives me 7 plus the root of 0 has to equal the root of 4 plus 5. So this is 7 plus 0, so that's 7. And on this side, I have 2 plus 5, which is 7. So that means x equals 0 is one of my solutions because it does verify. Now I have to do the exact same thing, but I have to do it with 12. So I'm going to have 7 plus the square root of 3 times 12 equals square root of 5 times 12 plus 4 and plus a 5. So I want to verify that the left side of the equation actually equals the right side of the equation. So 7 plus the root of 36. I want to see if that equals, well, 5 times 12 is 60 plus 4, square root of 64 plus 5. So I have 7 plus 6 might equal 8 plus 5, and indeed 13 on the left side, 13 on the right side. This does verify. So x equals 12 is also a solution to this question. So now that I've actually found the two solutions to this question, x equals 0 and x equals 12, we have to determine the restrictions to the original equation. Now the original equation had two radicals in it. It had the square root of 3x and it had the square root of 5x plus 4. So I want to determine what the restrictions of this equation would be. Now remember, if we're talking about an index that's positive or even, like we have here, we have indexes that are 2, we need the radicand, so the 3x has to be greater than or equal to 0. And in this case, the radicand, 5x plus 4, has to be greater than or equal to 0. So if we start solving this, x has to be greater than or equal to 0. Just divide by 3. On this side, I'm going to have 5x is greater than or equal to negative 4. Then I divide the 5 out. X has to be greater than or equal to negative 4/5. So both of these are talking about the same variable x. So we should kind of examine where this lies or what it looks like on the number line. So here's my number line. Let's say this is 0. Here's 1. Here's negative 1. The first equation says, my restriction, or the first restriction here says, x has to be greater than or equal to 0. So here's 0, greater than or equal to 0 is this stuff. All of those numbers would make this original equation true. The next one says, well, but x has to be greater than or equal to negative 4/5. Negative 4/5 is somewhere here, and it's saying as long as the numbers are bigger than that, we have this to be true. So I've got two things. I've got from this green dot on, and I have from that blue dot on. Only one of these would satisfy the original equation. This one says it has to be bigger than negative 4/5, but the other one says it have to be bigger than 0. So the one that satisfies both of them is x is greater than or equal to 0. As long as that happens, the x value would make both those radicands positive and would work. So my solutions to this question are x equals 0, x equals 12, with the restriction that x has to be greater than or equal to 0.